Now let's take a look at a graph of the cosine so that we can see a way that we can restrict the cosine function to where we will cover all of the values between -1 and 1 and be able to have an inverse function, but we won't have any repeating values. So if we restrict it from 0 to pi, we would cover all the values that cosine x takes on from 1 to -1 and not repeat any. And so that's what we will do, is restrict the values that we plug into, or restrict the domain for cosine of x so that we can have the inverse function. And the inverse cosine function, which is denoted in this way, it's otherwise known as the arc cosine, is defined to be the inverse of the restricted cosine when we're only going from 0 to pi on the cosine of x. So inverse cosine of x is the number, it's the angle that's in the interval from 0 to pi whose cosine is x. That means this time, since we're going from 0 to pi, we're going to be considering quadrant 1 and quadrant 2. Cosine refers to the x value, so if we've got a positive value that we're looking for, what angle did we start with? We'll think of a angle in quadrant 1. If our value that we're plugging into the inverse cosine is negative, then we'll look for an angle that's in quadrant 2 to satisfy that. So on this first problem, we want to know what is a value what is the angle whose cosine was 1/2. Since we're looking at a positive value between 0 and pi, then we're going to have to be coming from quadrant 1 on this one. So it's actually going to be between 0 and pi over 2 since it's a positive value. And so what angle gave us a cosine of 1/2? Cosine being the x values, and the one that gives us 1/2 is going to be up here at pi over 3. And so this one is going to be pi over 3 since the cosine of pi over 3 is 1/2. Okay, so that's how we get that. You can either show this work or that work. Either one's fine by me. The angle whose cosine is negative square root of 3 over 2. So again, we have to pick an angle between 0 and pi that gave us a cosine of negative square root of 3 over 2. That means we're going to have to come from quadrant 2 and look for an angle inside of quadrant 2 that gave us negative square root of 3 over 2 for the cosine, the x value over there. And so that means that we're going to want to come over here to 5 pi over 6 to get that point. 5 pi over 6 would give us that. Might be helpful to keep your unit circle with you while you're working some of these, especially when you're supposed to be getting exact values like this. So that is since, we know that to be the case since the cosine of 5 pi over 6 is negative square root of 3 over 2. So I wanted to let you know that you can check your answers in case you're not sure you're getting these right. You can check them. We could simply go in and say, well, let's see, the cosine of 5 pi over 6 does give me this, but is that negative square root of 3 over 2? Well, I don't know. Let's find out. Negative square root of 3 divided by 2. Yes, I got the same thing. So we did get the right answer on that one, as long as we picked an angle that's in the right domain between 0 and pi, and it is. All right, so how about what's the angle whose cosine is 0? Where in between 0 and pi do I come up with a angle whose cosine, whose x value is 0? Well, that's at pi over 2. So that one's going to be pi over 2. It wasn't in quadrant 1 or quadrant 2, but we can still check it out since the cosine of pi over 2 is equal to 0. Alright, let's look at some that are going to deal with the cancellation property, which we learned up here. So if we want to find the value where the inverse cosine of the cosine of 5 pi over 6. So we've got to make sure that this 5 pi over 6, we've got to make sure that 0 is less than or equal to 5 pi over 6, and it is, so far so good, and make sure that that's less than or equal to pi. Well, it is. This 5 pi over 6 does fall between 0 and pi. So we're going to use the cancellation property, and I'm just going to, well, I was going to abbreviate it, but apparently I'm not. Cancellation property, which says that our inverse function undoes our inverse cosine undoes the cosine, and we get 5 pi over 6. Now let's try this one. Is this 7 pi over 6 going to be between 0 and pi? Let's find out. So 7 pi over 6. It is greater than or equal to 0, but it's not less than pi. It's actually more than pi. So there it doesn't work. So we can't use the cancellation property on this one. We will not get 7 pi over 6 on this one. We're going to have to figure out what's the cosine of 7 pi over 6, and then we'll take the inverse cosine of that. So let's see, 7 pi over 6 on a unit circle, that's going to be passed here and down here by pi over 6. First of all, our cosine value is going to be negative, so we know we'll get something negative. It's the same value, only it's negative, as what we would get if we were doing pi over 6. So let's see, the x value there is going to be square root of 3 over 2. So we want to know what angle gave us a cosine of negative square root of 3 over 2. Well, that one's going to come in quadrant 2. And in fact, we already did it on the last page. We said that we get 5 pi over 6 for that one. And so that's the same thing we end up with on this one.